guys, in this video we're going to start talking about surface area. And before we do that, we're going to look at a couple different kinds of three-dimensional figures. And so one thing we can do to look at a three-dimensional figure is we can essentially unfold it into a bunch of two-dimensional faces. So this would be the 3D, and then this would be the net. That's what we call that. So the net, basically you can think of like I unfolded it into these two-dimensional faces, and I could fold it back up to be this three-dimensional figure. We can do this with a variety of shapes. So here's another net. This is the net of a triangular prism. Now, you might be like, well, how would I know that? So we have some different kinds of surfaces. So prisms, all prisms have rectangles for a lot of their faces, and then they might have a different shape. We're going to call these the bases. So this is actually a good image down here. So this is a prism, this is a prism, because they have rectangles that make up what we call the lateral area. And then they have a different shape for their bases. So the bases are always parallel to each other, and the lateral faces are rectangles, okay? We're going to come back to that a little bit more. We're going to keep talking about lateral area and surface area. Okay, so for lateral area, combined area of all, we're going to call these the sides. That can be misleading depending on which way it's oriented. The surface area, what we're going to be asked to find primarily, is the combined area of all the sides and, actually, yeah, we'll do this. I'm actually going to rephrase this, you guys, so it's a little more, we're going to rewrite it like this. Okay, so we're going to say the lateral area is the combined area of all the lateral faces. I'm going to use the same terminology there. Lateral faces. And then if they ask for surface area, we want that, the lateral faces, and the bases. So it's all surfaces we could possibly find the area for. Okay, so now we're going to practice just naming some different figures. So we're going to name the base shape first, and then the shape of its lateral faces. So if it's a prism, it has rectangular lateral faces. If it is a pyramid, it has triangular lateral faces. Okay, so here, this is a prism because it has rectangles for lateral faces. The shape of its base is a triangle. So we would call this one a triangular prism. So the gray is kind of highlighted here for us on a few of these as being the base. I'm going to do that on this one too, just to highlight. Okay, so the shaded region is kind of our base to help us out. So this is a rectangle. It looks like it could be a square. I don't know that for sure. So I'm going to just call it a rectangular prism. This base is a pentagon, so this would be a pentagonal prism. And now these next three are no longer prisms because they no longer have rectangles making up the lateral faces. These are triangles that are coming together at a single point. And so we still name the base first. So this one is a rectangular, but this is a pyramid if all the lateral faces are triangles. Okay, so this is a rectangular pyramid. This is a pentagonal pyramid. This one is a hexagon, 6 sides, so it's a hexagonal pyramid. Okay, so that's just kind of getting more familiar with the name. So the two we're going to focus on today are types of prisms and types of pyramids. Okay, so we are going to start with prisms. Okay, so prisms, we can name the shape again by its bases. So it's going to always have two parallel bases. So this is a rectangular prism. I'm going to go ahead and calculate the surface area of this. Okay, so surface area is all the different faces added together. So you can imagine this, you guys, as we have kind of 3 different sizes of rectangles involved. So we have the front and the back. So the front and the back are 5 centimeters and 4 centimeters. And we have 2 of those, right? Because I have the front and the back. Okay, the other one I have is I have these 2 sides, the right and the left. And those dimensions, right, it's 3, this is also 5, so 3 by 5. Again, we have 2 of those, and we've got 3 and 5. And then the last I have is I have the top and the bottom. And again, those dimensions, I've got 4 and 3, and we have 2 of those because we have the top and the bottom. So this is one way to calculate the surface area, is we kind of go like piece by piece, and it helps if you recognize, hey, I have a few pieces that are the same, so I just calculate it once and then multiply by how many of those there are. So in this one, we have the area of a rectangle, right? It's just base times height. So I'm going to do 4 times 5, and then times 2, because I have 2 of those rectangles, okay? When I multiply those together, we get 20 times 2 is 40. And then the second one, we're going to do 5 times 3 times 2. Okay, which is 15 times 2 is 30. And the last one, we've got 3 times 4 times 2. So 12 times 2 is 24. So our surface area, I'm going to use SA for surface area, is add all 3 of those together. So 40 plus 30 plus 24 is 94. This is an area, so we're adding those together. Okay, and this is an area, so our units are still square units. So this is going to be, sorry, I'm going to write this actually over here. Surface area is 94 centimeters squared. Okay, all right. Now we're going to do this triangular prism. Okay, so the triangular prism, again, we are going to break into its faces, okay? Now, this one, you guys, doesn't look super great because we have a triangle that doesn't necessarily look just like this triangle. So we are going to work with that in just a second. Here I have 3 rectangles. Actually, I'm going to kind of treat this a little differently. So my bottom rectangle, right, is 6 by 12. Okay, 6 by 12, that's the bottom rectangle. Now, I don't necessarily have the same rectangle 3 times. We actually only have 2 more that are the same, kind of the sides. Okay, again, I'm just going to call it the sides. Okay, so these ones are 5 by 12. This one over here is also 5 by 12. So we're going to multiply that one by 2. So we have 12 times 5. We do not have this, guys. I don't need that one. Okay, so this one's multiplied by 2. This one I only have 1 of those. The other thing I have is I have the triangle. Okay, so now this triangular prism, what I need to find the area of the triangle is base times height divided by 2. So I'm actually going to split this one here in half, you guys. So I've got 6, 5, 5, right? Well, I don't have the height. We need to find this height. So what I'm going to do is I'm going to deal with the right triangle. So I'm going to kind of blow this right triangle up and use this guy. So half of 6 is 3. We know the hypotenuse is 5. If I do a squared plus b squared equals c squared. Also, you might just recognize this is a 3, 4, 5 triangle. This has to be 4. You can check that if you do 3 squared plus, I'm going to call it h for height, equals 5 squared. So we get 9 plus h squared equals 25. Subtract 9 and take the square root, and I get h equals 4. So that's where that comes from, okay? But if you see a 3 and a 5, 4 is automatically the third component to that Pythagorean triple. Okay, so we didn't need this one. So we have 2 of these triangles, right? So the area of this triangle is base times height divided by 2. So we've got 3 times 4 divided by 2, and then we have 2 of those, right? Times 2 for the 2 triangles. So here's what I got. I got 3 times 4 over 2 times 2. Okay, when I do that, I get 12 divided by 2 is 6, but times 2 again is going to give us 12. The bottom is 12 times 6, which is 72. And this guy we had, sorry, that was a 5. So 12 times 5 times 2, because we had 2 of those. And when we multiply that, we get, what, 6120? Add these 3 together, so we get 84, 204. So our surface area is 204, and our units here are square centimeters. Okay, so this is kind of a method just to help you break it down and see the individual pieces, that we're just finding the area of each piece and then adding it together. Okay, I'm going to stop there, you guys. We're going to do a separate video for pyramids. Thanks for watching.